Hello everyone, welcome to Get Java. So as we have seen in our previous video that Java is a platform independent language. So today we will be seeing how Java works internally and how it is able to achieve its platform independent feature. So let's get started. Suppose we have written a Java program in a file called firstprogram.java, where first program is the name of the file and .java is the extension of the file. So all a Java program will be written in a file having .java extension. So my file name is firstprogram.java. I have written my code inside this file. Now I want to execute this file on our machine. It can be a Linux machine, it can be a Windows machine, or it can be a Mac machine. So can we execute a Java code directly onto these machines? The answer is no. Because as we all know, Java is a high level language, that is only humans can understand what is written inside the code, but machines understand only ones and zeros, that is binary code or machine code. So we need a mechanism to convert this high level language into low level machine code. So how we will do that? So here comes Java compiler to our rescue. The main job of Java compiler is to check if there are any mistakes present in our Java code. If there are no mistakes, it will convert a Java code into bytecode, which is represented by .class file. It will have the same name as a main file, that is first program, but it will be represented by an extension .class. And to convert our Java code into bytecode, we have to execute this command, which is javac and our file name firstprogram.java. So now we got the bytecode. Can we execute this bytecode onto our machines directly? The answer is still no, because bytecode is kind of an intermediate code which even humans cannot understand nor machines can understand. So now we need a mechanism to convert this bytecode into machine code or binary code. So here comes JVM into picture. So what is JVM? JVM is nothing but Java virtual machines. So basically we can assume it as a translator which will convert our bytecode into machine specific code. So for example, in Windows, the JVM for Windows will take the bytecode and it will convert it into machine code for Windows. Similarly, JVM for Mac will take the same bytecode and convert it into machine code which Mac can understand, and so on. So basically you can assume JVM as a translator which takes the bytecode and convert it into platform specific machine code. Now, although JVM performs many more functions which we will be seeing in upcoming videos, as of now you can assume it as a translator for converting bytecode to machine code. So you might have a question like, why we have to convert this code into bytecode first and then to machine code? Why not convert it directly to machine code? To understand this, we should know what all task is done by compiler before converting it to bytecode. So the compiler takes a Java code and it converts it into an abstract syntax tree, which is nothing but a in layman's term you can understand it as it will take your code, it will remove unnecessary information, and it will create a tree with certain parameters which are important, and it will be useful by JVM to understand your code in a more better way. So basically it is making your code more compact. Also it will check if there are any syntax errors in your code. So compiler will check and let you know if there are any errors in your code. Also in some cases it optimizes your code before converting it to bytecode. So if we are skipping this step, these all tasks needs to be done by JVM, which is an overhead for JVM. So basically it will degrade the performance of JVM. So Java compiling the code is very much necessary. Now this bytecode we are executing across all platform with the help of JVM for that platform. So since we are using the same bytecode and running it across all platform, it is also known as write once, run anywhere. We are writing the code only once and we are running it across any platform. anywhere we can run the same bytecode. So that's why it is also known as write once, run anywhere. And for executing the code, we will be using this command java and name of the file. So we will be seeing how to do it practically in our upcoming lectures. I hope it is clear to you now. If you still have doubts, I have created an analogy where you can consider some alien from outer space is trying to communicate with humans, but alien language we cannot understand. So alien language we can consider as Java code. So NASA takes the language and decodes it and convert it into English language, which is an intermediate language. So we can consider NASA as compiler. It takes the language, it converts it into English, but still English cannot be understood by native speakers, someone who speaks German or French or Spanish. So we need some translator to convert this English to the native language. So JVM act as a translator for converting English to German. Similarly, in Java code, it takes the bytecode and convert it into platform specific machine code. So we can consider JVM as translator. So I hope it is clear as of now. If you still have some doubts, you can mention in the comment section. Now we will be seeing some interview question related to working of Java. So let's have a look at some of the interview questions on this topic. First question is how Java works internally. So we have already discussed about it. Second is how Java is platform independent. Again, we have seen how Java achieves its platform independency. Now, third question is Java platform independent? So yes, overall Java is a platform independent language. We have seen this. Is bytecode platform independent? So again, we have seen that same bytecode we can execute on any platform, be it Windows, Mac or Linux or any other platform. Same bytecode can be executed on different platforms. So is Java compiler platform independent? So here Java, it's asking about Java compiler. So Java compiler, when you download the Java software for Windows machine, you will get compiler for Windows machine. Same compiler you cannot use in Mac or Linux. So it's not platform independent. So answer is no. Is JVM platform independent? Again, JVM is not platform independent. So we have seen we have different JVM for different platforms. So JVM for Windows will convert bytecode to Windows platform specific machine code. Similarly, if you are using Mac machine, it will have JVM for Mac, which will take the bytecode and convert it into machine code for Mac machine. So the answer is no. So these are the interview questions on this topic. I hope you like the video. If you have any doubts, you can mention in the comment section. Thank you.